Alright team, let's talk standard variant in modern C++. Imagine there is a situation where you want a container-like object that can hold any type of value. The container needs to be type safe and it should hold a value of one type only at a time. Right? To solve this problem, you might have used something like a union in C programming language, but in C++ there are much better alternatives that you can use. So today we are going to look at a, a class, right? A class called standard variant, and this class can hold values of multiple types, right? So let's declare a standard variant here that can, let's say, hold a double, a int, a float. Let's give it a char as well, and let's give it a standard string, right? Let's call this variant v. So in this case, this standard variant can hold either an int, a double, a float, a char, or standard string, right? In this case, we have not given it a value, so by default it holds a value of an integer type, right? And let's prove that. So if I see out, and this variant provides a function called index, right? And the index function basically tells you which type of value is currently stored in your variant, right? In this case, because we haven't stored any value in it, we should get an index of 0. Like I said, by default it will store the value of the first type, right? So if I run this program, you should see a 0. Now if I put some value in this variant, let's say, let's put a string. Let's put a string called hello world, right? And let's print out the index again. You should first see a 0 and then you should see a 4, right? Why did we get a 4? Because now the variant holds a value of type string, which is 0, 1, 2, 3, 4. Fourth type in our variant. Alright, so before we make any further progress, let's add like a very simple helper that prints the value in our standard variant, right? So let's call this helper print, and let's say it takes in a standard variant of this particular type. And so the challenge now is, okay, our variant can hold any value of these mentioned types, right? So how do you make sure that, or how do you find out what type is currently in the variant? And there's a very nice function that you can use called, it's called standard holds alternative, right? It's holds alternative, and all this function does is it checks the type in your variant, and if it's a specific type, it returns a true or a false, right? So we can give it our variant v, and then if this check will pass if v has a type of int, right? So we can then simply print the value to our output. So for getting the value, we can use standard get, right, and type int, and then we can get the value, right? And if we do this for all the types that our variant can hold, we'll probably get a chance to, like, print any value of a specific type. So let's do add if check for double, let's add an if check for float, let's also add an if check for char, and finally we can add an if check for standard string. Alright, so next let's make use of of this new function that we developed here, right? Let's minimize it for now, and let's say we want to use it. So what we can do is let's remove this code, right? And let's start by adding an int to our variant. Like let's say let's add 99, and then let's call print v, right? So if I run this, hopefully we should see 99, right? Let's now add a double, right? So let's say 66.55, right? So if I print this, we should now see a value for the double, right? Let's put in a float value 4.4f, right? If I run this, we should see 4.4f, and similarly, I think you get the idea, right? So we can do char, we should see a char value getting printed, and if we put in a string, let's say hello, we should see a string value getting printed. So the variant has to hold the values that you have mentioned during the declaration type, right? If you try to put in like a crazy value in there, let's say for example, let's say we make this variant not hold, or it not hold a string anymore, right? And our last statement here puts in a string. So if we then try to print it, you're going to see an exception. Well, first of all, you won't even be able to initialize the variant, because it's going to say, okay, you're trying to put a string in here and the type is not supported. So the other problem I want to talk about is if you try to get a value that's, or a type of value that's not in your variant, the variant has a there's a chance that a variant can throw an exception, right? So let's see that in action. Let's say our variant has an integer value in it, and let's say you're trying to get a double from out of it, right? Which is supported, but the value currently in your variant is an integer, right? So if you do something like this, you will see an exception coming out saying that, hey, you are currently, okay, let me comment this out. There you go. So terminate called after throwing an instance of standard bad variant access, right? All it's trying to say is, hey, your variant has an integer in it right now, and you're trying to get a double value out of it, which is clearly wrong. So you will get some kind of an indication, in this case an exception, that's saying, hey, you're wrong index for variant. Alright team, so hopefully you understood something about standard variant, and as always feel free to experiment with it. Standard variants are a great way to have type safe containers, right, that can store one value and can be of multiple types, right? They also ensure that only one value is active at a time, and you kind of get this nice container that can store those values in a safe way, right? Variants, I think the main use case for variants is mainly you you want to avoid union style structures that were developed in C programming languages, and make like a better, safer container to hold values of different types, but only one type at a time, right? So hopefully you enjoyed this video, and if you did, please hit the like button. If you have any comments or questions or feedback, post them in the comment section, and I would be more than happy to reply back to you. All right, see you next time. Thank you very much.